Alrighty, well here we are. We are working on 2013 question 1. It is all about a gravel plant, and I'm really hoping you've already read it. Let's see, it says, on a certain workday, the rate in tons per hour at which unprocessed gravel shows up a plant is given by this equation. When they say that they're giving you a rate, that's an important term. A rate is kind of like a derivative. So really, they're giving us, well, it's supposed to say derivative. Of course, it would be better if I could spell. But so really, g of t is kind of a derivative function. And it's measured in hours from blah, blah, blah. And it says at the beginning of the workday, the plant has 500 tons of gravel, unprocessed gravel. And then during the operation, the plant processes gravel at a constant rate of that. So, well, here's what's going on, just in case you're having trouble visualizing what's happening here. What's that little eraser doing there? Oh, weird. Okay, you've got some plant, and it's got a big mound of gravel. And at time equals 0, it says at time equals 0, it starts with 500 tons of gravel. And all the time, there are a bunch of semi-trucks, and they're coming in, and they're dumping. Maybe they're, they've got their big dump truck things, and they're backing up. And they're dumping gravel into the pile. And that is the rate that they gave us. That is the g of t, not g of x. So that's how fast they're dumping gravel in. And also, you've got some sort of a processing plant, some sort of a conveyor belt that takes the stuff into the giant pollution-making factory. And this is processing gravel at 100 tons per hour. Okay, so I'm hoping that makes sense. We have stuff going in, and we have stuff going out, and we have stuff that we started with. So that said, I don't think you get extra credit on the AP exam for making cool pictures, but I like my picture, so we're going to keep it. Whoa. Okay, so we have a picture in case we need to come back to it. Okay, well, let's see. If you're a smart cookie, then you realized as soon as you saw this problem, and as soon as you saw it was a question 1, you realized, oh gosh, this is calculator active. So I'm going to grab my TI-89, and oh, it's already on. And you're going to type this equation here into y1. So you go y equals, and we type it in. It's 90 plus 45 times cosine, parentheses, but they already put a parenthesis there, x to the second divided by 18. Enter. Okay, so we've got that thing there. And let's see what it asks us for. It says, find g prime of 5. Well, g prime is the derivative of this thing, and we have a calculator. So hopefully you remember how to do this. Hopefully you sped through this part of the video. What we have right here is we have y1. y1 right now is currently defined as my g function. And so what I'm going to do is I'm going to take y2 and make it the derivative of g. And to do that, I'm going to type in derivative, so the d is above the 8, so second derivative. And then I have to type in y1 of x, comma x, and that's it. Enter. So y2 is the derivative of y1. And I'm going to go to the home screen and clean that mess up. And I'm going to say, well, what is y2 of 5? And bacon that thing, second bacon. And it tells me it is negative 24.587. So now it's time to write some work, to write some answers. I'm going to say A, g prime of 5 equals negative 24.587. And it's probably going to ask us for some sort of a explanation. And, yep, using correct units. Well, G is the rate in tons per hour. And so if we take the derivative of G, we're getting tons per hour, or tons per hour squared. So it seems like if we're interpreting this answer in the context of the problem, this is the rate, G prime is the rate of the rate. So we're really saying that was a very bad explanation. Well, let's see. If the rate were steady, say like at 100 tons per hour, this would be constant. Our rate is changing. And so it's saying that the rate at 5 hours is changing. Is it speeding up or slowing down? Well, it seems to me that it is slowing down. I'm going to hit my little record and take a... Okay. So the rate at which gravel is entering is negative, so it's slowing down. So sometimes the thing that I try to do, because I know that these interpreting the answer in the context of the problem is tough for a lot of people, I try to use the language that they gave us. So they said G of t is the rate at which unprocessed gravel is arriving. So I could say maybe I'll use exactly that language, and I'll say the rate at which gravel, I'll just say gravel arrives is, and now instead of saying is negative, I'm going to say it is decreasing by 24.587 tons per hour squared. And I would like to think that I'm thinking 2 points. I don't know about you guys. Think that's worth 2 points? Darn well better be. So here is the grand reveal. Whoops, not that. Here it is, the grand reveal. Dun, 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 dun. Oh no! Oh no! What did I do? Let's get this guy up, and where did my answers go? Oh, he got detached. Bad detached answers. She's so much moving around. Let's see. Well, we got the value right, and the rate at which gravel is arriving is decreasing by that. Okay. Oh boy. Probably I should have put that at t equals 5 hours. At t equals 5 hours. Rookie mistake. Alrighty, let's move on to part B. Boom. Part B says, find the total amount of unprocessed gravel that arrives. So notice, if we go back to, and see, I get to use it, if we go back to the picture, we don't care about the total amount in the pile, we just want the total amount that arrives. Boom. The total amount that arrives at the plant during the hours of operation. Well, that's from 0 to 8. Well, again, since they gave us a rate, since g of t is a rate, it's kind of like g of t is a velocity. And if they want the total amount, well, then they're asking us for a total distance. And so we would integrate. We'd say that total amount is going to be the integral from 0 to 8 of g of t. And I'd write that down, and then I would go to my calculator and punch that baby in. So clear that thing out, and I'm going to say that's my y1. This one here is y1. So I'm going to say it is the integral, which is above 7 integral of y1 of x, comma, 0, comma, 8. And then bacon. As I say, if this were the real AP test, I'd be looking ahead at part C. And so it says 825.551 tons. And I would be shocked if we get more than 1 point. Maybe 2. Maybe they give you a point for the answer and a point for the setup, but I kind of doubt it. Let's see. Oh, 2 points! Dang, that's just amazing. That is really amazing. 2 points for that. Alrighty, moving on to problem number 3. You can come in. The custodian's out there, and he's afraid of me because I'm wearing these crazy headphones that look like an alien. Moving on to problem number 3. Okay, is is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5? I'm going to pause this and go save the porpoise. Okay, I think he's not too much afraid of me anymore. Alrighty. Let's see, is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5? I am so proud of my little drawing here because it's actually turning out to be kind of useful. I wonder if I can copy and paste it. Let me try to copy this thing and then go forward, and maybe I'd have to grab my mouse and right-click paste it. Please be there. Paste. There it is. All right, so yeah, it's asking, is the amount of unprocessed gravel increasing or decreasing at t equals 5? Well, we have outgo, and we have input. And if they're asking, is the amount of unprocessed gravel at the plant increasing or decreasing, what they want to know is this stack getting higher or getting lower? And if you just think about it, well, if the stack is going higher, it would seem that it's coming in faster than it's going out. And if the stack is getting lower, the stack is decreasing, that would mean that it's going out faster than it's coming in. So I guess what we want to know is, well, we know how fast it's coming out. It's 100 tons per hour, steadily. Not tons per year, tons per hour. And so I guess the question is, how fast is it coming in at t equals, whatever they said, at t equals 5? Gosh, if only we had an equation that told us how fast the gravel was coming in at t equals any time. Oh my gosh, they gave us one. So really all we want to know is, what is g of 5? Because g tells us the rate at which stuff is coming in at any moment. So I'm going to go to my calculator. I'm going to go on, and I'm going to say, clear, what is y1 of 5? And bacon, boom, 98.14. So we know it's coming in at 98.14. I better not lose a point for a decimal, 0. And it's going out at 100. So you tell me, tons per hour. Is the pile growing or shrinking? And it seems to me that if it's coming in at that and going out at that, the pile is growing. No, shrinking, duh. Yeah, because it's being processed faster than it's coming in. So now it's just time to write an answer. Show the work that leads to your answer. It's not a lot of work to show. I think for showing the work, you would say g of 5 equals, and then write that number, 98.140. And you could even write words. You could say gravel is being processed. Gravel is processed at 100 tons per hour. Tons per hour. Maybe I should put some tons per hour. And I'm going to put a little 3 dot, therefore, and I'm going to use their language, the amount of unprocessed gravel, amount of raw gravel is decreasing. And just to be thorough, I'm going to say at t equals 5. Let's see how we did. Well, we got 2 points for the last two. Maybe this is worth 2 points. I don't know. Let's find out. 2 points. Well, let's see. We got a point for comparing G5 to 100 and a point for coming to the right conclusion. I'm probably writing a few words or something. And I think we just got our 2 points. Dang, we're up to 6 points already. Rock and roll. Let's go get 9. Boom. Number D. Wow. I'll hide that for a little. Hey, what did I do? Oh, there it is. Okay, number D. What is, this is where they're going to make us earn those last 3 points. What is the maximum amount of unprocessed gravel at the plant during those hours of operation? Okay, I'm going to pause. Okay, I wanted to get my picture there because it's such a good picture. The maximum amount of unprocessed gravel at the plant. Well, if you think about it, again, we have the income, input, and outgo. And so if you think about it, the gravel is going to be a maximum as long as the input, this input, has been exceeding the outgo. Gosh, if only we could see maybe a graph of what this looked like. Oh, hey, we have a graphing calculator. So I'm going to go on, and I'm going to go back to y equals, and I'm going to get rid of that derivative function. We don't need derivatives anymore. And just for kicks, I'm going to graph this thing and see what it looks like. It's probably going to be crazy. Ooh, it looks like my scale is weird. So maybe window and 6. No, I don't want to do that. I want to go backspace 0. Oh, we can change that from 0 to 8. 8. And what are my y's doing? Y's are the gravel. Let's go say -50 to, I don't know, we could have a lot of gravel. I'm going to go 500 and see what that looks like. Whoops, oh, and I'm going to count by 50s just to see what it looks like. Oh, why do I keep doing that? I want to graph. Oh, there it is, graph lay. Okay, so this is my g of t function. It looks like I can change my scale a little bit because my y's are kind of big. So I'm going to go back to window and maybe make my y's go down to, say, 250 and graph. Okay, that's a little bit better. So that's the rate at which gravel's coming in. It would certainly be easy to graph the rate at which gravel's going out. That's 100. So I'm going to go to y2 and put in 100 and graph that. Whew, there it is. So it looks like, I'm going to sketch this thing. That's, color code. Here's my input. Woo. And here's my outgo. Wah. So it sure looks like we have more coming in than going out until we get to that point. And then we have more going out than coming in. So I'm thinking it would be really nice to find that point. Hey, we have a calculator. So I'm going to go, let's see, go to graph F5 math. I want to find an intersection, enter, first curve, enter, sure, second curve. For a lower bound, I want a left edge. Well, I'm on the left edge, so I'm going to hit enter. For an upper bound, I want a right side of that point of intersection. So I'm going to go over there and hit enter. And my calculator tells me something. It tells me that this point, 4.923. And so what I'm going to say right now is that's where my g of t function equals 100 at t equals 4.923. And if you're clever, you just store that as a just in case. So I'm going to go to, I don't want to distort. What do I want to do? I want to go home and then hit clear and then hit X alpha C, store as alpha A, because I think I'm going to need that later. Okay. And maybe go back to the graph so we can see a picture of that. Okay. So I'm thinking that it's very possible that at this point, the amount of gravel at the plant is a maximum. But wait, because it's an AP test and they're going to put multiple points on this, we should check to see, since they give us a closed interval, how much gravel is at the plant at 0 hours, how much gravel is at the plant at 8 hours. So now I'm going to get ready to, let's see if I minimize that thing. Are you going to let me minimize you? Go away. Really? Okay, fine. Okay, whatever. Uh-oh. I better pause because I think it's freezing up. Maybe. Pause. Uh-oh, nothing's responding. Huh. Well, can I move my mouse? Stop. Oh, this is a disaster. Oh, no. Hey, if I were you, I would, well, what can you do? I don't want to pause this thing. I don't want to delete the whole video because that would be a real hassle. Please don't do this to me. Okay, maybe if I kill the calculator, maybe the calculator's screwing it up. Sorry about this, guys. Hopefully you're getting a snack or something right now. Let me go. Exit and save state. Sorry about that. It seemed not to like the calculator, so I had to get rid of that, and we'll see if I'm able to pull it up again. Okay, so now it's time to do some math. So we know this is a possible point of maximum point, and I think I just got done saying we should check some endpoints. So at this point, I would maybe write a sentence. I could say maybe the amount of gravel could be a maximum. Amount of gravel could be a max, could be a maximum at t equals 0, t equals a, right, because we already defined our a, or t equals 8. And so then I would make a table for time, 0, a, and 8, and we're going to find the amount of gravel. Amount of gravel at a certain time equals amount of gravel. Okay, at t equals 0. Well, that's the only easy one. At t equals 0, it tells us the plant has 500 tons of gravel unprocessed. So I'm going to say 500. At t equals a, at this time, well, we need to think about, we have 3 things going on. We have how much gravel we started with, how much came in, and how much went out. So I'm going to say at t equals a, that amount, I'm going to say the amount of gravel at time a. And I notice I just made up this new amount of gravel function, but I did define it up here, so I can now say use it. The amount of gravel at time a is going to be how much we started with. We started with 500. Plus how much came in. Well, the input would be the integral from 0 to a of our g of t function. That's our input function. Minus the output, and the output would be 100 tons per hour times the number of hours, and it has been a hours. And I can tell you that right off the bat, I kind of wish I had rearranged this thing, because this negative 100a at the end, it's not entirely clear whether it's part of the integral or not. And so I might even rewrite this thing and say it's actually 500 minus 100a. And then, oh good, now it's letting me move that thing, plus the integral from 0 to a of g of t. And then I would, write that, and I would probably just scratch that out if this were my AP exam, because I'd want to make it perfectly clear to them that I knew that was outside of the integral. And now it is a calculator exercise, so that's going to be fun. I'm going to pause and see if the calculator can come back up again. Okay, we're back, and hopefully it will like the calculator now. So I'm going to go to my home screen. Oh, please let me, please. Okay, good. Okay, so what we have is 500 times 100, oh, we're not 500 times, silly me, backspace, minus 100 tons per hour times a hours, alpha a, plus the integral of y1 of x, comma, we're integrating from 0, comma, to a, alpha a, bracket, and bacon that thing. And I am guessing there is no part E of this problem. Ooh, it tells us that amount is 635.376 tons. Okay, and then just to be thorough, we should find the amount of gravel at time t equals 8. So even though we can see from the picture that it's going to be, we can see from the graph that, well, we could see from the graph that gravel was entering at a lower rate than it was being processed. So the amount of gravel is decreasing, but we want to be thorough. And so we're going to say the amount of gravel at time 8. Well, that's going to be 500 that we started with, minus the 100 times 8 hours that it's been, 100 tons per hour, plus the integral from 0 to 8 of g of t. And the good news is that we have most of that in the calculator already. It's just a matter of changing a's to eighths. And so I'm going to go scroll over here and backspace that a and make it an 8. And go over here and backspace that a and make it an 8. And bacon this thing. And I have not checked the answers, so if all of this is wrong, lucky me, I get to redo this entire video and go home really late, or else make you sit and watch through all of my corrections. There it is. It's 525.551. So I get that equals 525.551. Okay, and we can now actually answer the question with confidence. We can say the maximum amount of unprocessed gravel is, we've justified the answer with work, so we can say the max amount of, and again I'm going to use the word raw because it's shorter to say than unprocessed, gravel is, what did we decide it was? Calculator's hiding it. 6.35.376. 6.335.376 tons at T equals 4. Whoa, better yet, A. I already defined it. I don't want to screw up with a decimal. Maybe if I'm super confident, I'd have the guts to write it in. 4.923 equals 4.923. Let's see how we did. Dun, 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 for the big reveal. Oh, please be right, please be right, please be right. Phew! Yes, we got it. We got our 3. We considered where the slope is 0, where A prime is 0. Did we? A prime is 0. We're going to be okay, because what we considered is where g of t equals 100. And that is, I know that seems crazy, but it is equivalent to a prime being 0, meaning, okay, they gave us this thing, and I know this looks all scary and daunting, but they said, they also wrote an equation here for the amount of unprocessed gravel. They said the amount at any time is 500, what we started with. Aren't they overachievers? You could have said minus 100t. Yeah, they put it inside there, and when they integrate it, they're going to get a t by there. They're just like crazy. That's so perfect. Integral 0 to t of g of s. Don't freak out that they put an s there. That's only so that they could have a different variable on the inside of the integrand as opposed to on the once it gets integrated. And the fact is, if you did take the derivative of this, I mean, this is an amount function, and they asked for a maximum amount. Well, the maximum amount would be where that slope is 0. And if you take the derivative of this, you get negative 100t plus the integral from 0 to t of g of s equals 0. And that would mean that the integral from 0 to t of g of s would equal 100t, which is exactly what, oh, I'm sorry. What am I thinking? Poor you having to listen to me. I forgot to differentiate. Derivative of that is 0. Derivative of negative 100t is negative 100. The derivative of an integral is the function. Sorry, guys. I want it to equal 0, and that's where g of s equals 100. I knew where I was going, I just kind of got distracted along the way. It happens. So really, we just considered where g of s equals 100. So we're going to get all 3 points. And just in case, we could, let's go see what the most brilliant kid in the world did, just in case you want to see that. Here, let's check it out. Dun, 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 dun. And let's grow this baby. Boom. So, minimize that thing. Most brilliant kid in the world always gets 9 out of 9. And I'm just going to scroll straight ahead to D. Oh, well, aren't they just amazing? Most brilliant kid in the world did do this, and I can't write in this anymore because I'm not in smart. But they did say 0 equals g of t minus 100, and oh my god, did they try to solve that? That's nuts. You don't need to do all this. The graders know you have a calculator. So you could have written this, and then you could have written an answer. And we did both of those things. Maximum amount must occur at an endpoint or at a critical value. Boy, this guy's got all the vocab. At an endpoint or a critical value. You don't need to write those things. We can say the maximum must occur. We did. We said at equals t equals 0, 8, or in between. And I think actually our work is a little bit tidier than this. The handwriting is kind of amazing. So that's the most amazing kid in the world, and I think I'm just going to call it quits from here because I think that's been sufficient. Toodaloo, people. See you next class when you have almost no questions.